Okay, here we have a question talking about magnesium oxide reacting with hydrochloric acid to make magnesium chloride plus water. Student wants to find percentage by mass of magnesium oxide in the tablet. So they do a few steps, including a titration, and then finding out how much excess acid is left at the end of that titration. So this usually when you have 1 to 7 steps, it's usually a back titration question, which means you work from the bottom upwards. So you start with step 7 and work your way upwards. But before we do that, let's answer question A, which talks about percentage uncertainty. And the formula for this is, well, we have to read the first 2 steps. They place a beaker on the balance and record the mass. And then in step 2, they record the mass again after adding the 6 tablets. So when you have 2 readings, you multiply your uncertainty by 2. So percentage uncertainty is 2 times the uncertainty over the measurement. So in this case, it's going to be 2 times 0.005 all over the measurement, which is this mass of 6 tablets, 2.14. And we times that by 100. And to get, putting this on the calculator, we get 0.467%. Brilliant. Now moving on to part B, calculating the moles of hydrochloric that was added to the tablets in step 3. Now this is a 1 marker, should be pretty straightforward. Step 3 here, we add 25 centimeters cubed of 2 mole DM cubed hydrochloric acid to the beaker and stir till all the magnesium oxide has reacted. Perfect. We've been given everything. We've been given our concentration and our volume, which is 2 moles per DM cubed, and our volume being 25 centimeters right here, 25 centimeters cubed. Now the equation we use to find the moles is concentration equals moles over volume. So substituting that in, we get 2 equals n over 25. Now some people might say, oh yeah, simple, right? 50 moles. Unfortunately, you wouldn't get the mark there. You have to notice that the volume is in centimeters cubed, and we have to be consistent with our units here. So we have to divide by 1,000 to get into DM cubed. Now multiplying across, we get 0.05 as our moles for hydrochloric acid. Perfect. Now on to the big 6 marker, the one everyone's been waiting for. So I'm going to follow my kind of method from starting from step 7, right? Starting, as it's a back titration, we start backwards to forwards. So let's start at step 7. We add 0.09 moles per DM cubed of NaOH from a burette. We add it until the indicator changes color. So to our kind of flask that is where the titration is taking place. So we know our concentration, right? And we want to figure out our volume, right? To find out how many moles we have. Well, we can kind of do this, right? Because we have our mean titer, which is 20.38. And we know that this sodium hydroxide is basically the titer, right? Or what is being used as the titer. Because it's what is being titrated against, right? So our sodium hydroxide is our titer. So that means we've put in 20.3, well, our mean, 20.3 centimeters cubed of NaOH. Now we have our concentration and we have our volume. We can do the same thing as we did in part B and do C equals N over V and to find out our moles. So let me just write that smaller so we can fit all the steps in. So we can do C equals N over V and say that 0.09 equals N over 20.38. And again, that was in centimeters cubed, so dividing by 1,000, timesing it across to get the moles of sodium hydroxide being 0.001832 moles. Yeah. Now, that's first mark there. We started for step 7. Now let's work our way back up. Step 6 won't really help us. 3 drops of a suitable indicator doesn't do anything. Let's see what we can do. Now, before I do anything, I notice this equation up here, right? And this equation up here. Well, I found the moles of NaOH, so I can actually find the moles of HCl, right? The moles of HCl since it is a 1-to-1 ratio, is going to be the same as the moles of NaOH. So 0.0018342 moles, right? Now, here's where a lot of students get mixed up. This is in 25 centimeters cubed of solution, right? We looked at 25 centimeters cubed of this titration, basically, right? So remember, this titration, when you have your conical flask and then your massive burette, right? So your conical flask and then your burette that you have up here, and then it basically slowly kind of drips off into the conical flask, right? We took 25 centimeters cubed and put it in this conical flask. And if we work our way back up to one more step, it says the mixture was made up to 250 centimeters cubed in a volumetric flask. So we originally had a volumetric flask with 250 centimeters cubed, but we took only 25 centimeters cubed and put it in our titration, right? So for this to be amount of moles in 250 centimeters cubed, we have to times it by 10. So doing that, we get 0.018342 moles. Now, another thing with these back titration questions is there's going to be a compound that is used in more than one way, basically, right? We've got an HCl here and a HCl here, right? This is where part B comes in. Usually, they never ask you to calculate, this kind of part B of a question without actually using it, right? So, obviously, percentage uncertainty is an exception, but part B is actually used in part C. So, here's how. We know that originally that from step 3 that 25 centimeters cubed of 2 moles DM cubed hydrochloric acid was added to the beaker. So this is in the first reaction because remember it's referring to magnesium oxide here. So we know that it's not this equation, it's going to be this one, right? So here we have 0.05 moles, right? So originally we had 0.05 moles, and we actually have this much left after the reaction happened, right? Because this 0.018342 moles of HCl was used in titration, right? Or not, it wasn't used in titration. The NaOH was used in titration, but because we had a 1-to-1 ratio, right, we can just say that it was used in titration, I guess. Obviously, the actual element that was used in titration was NaOH, but same thing applies, right? So this 0.018342 was after the reaction happened. So to find what actually happened in the reaction, we just subtract it. Because originally we had 0.05, and after the reaction we had 0.018342. So subtracting it gives us 0.031658 moles. Now that is the HCl that reacted. Now remember, let's go back to our first equation. We've got MgO plus 2HCl gives us magnesium chloride plus water. Now, we know the ratio now, it's 2-to-1, or 1-to-2, whatever you want to call it. So, to find the moles of MgO, we can just divide by 2 now, right? So this is the amount of moles we actually want. This is the one, that happened in the reaction, if that makes sense, right? The one that actually took place in the reaction, which will help us find the percentage by mass of MgO, because now if we divide by 2, so 0.031658 divided by 2, we get 0.015829 moles. Now, the mass, this is the mass of, moles of MgO in 6 tablets, right? So we don't need to do anything by dividing by 6. Some people might be like, oh yeah, so don't you divide by 6 now to find the mass in 1? Well, no, because the mass of 6 tablets, and it's asking us for the percentage by mass of MgO, but we used the mass of 6 tablets. We used this 2.14 grams, right? So all our results, we use the 2.14 grams, we use the 20.38 titer, so we don't need to do anything like dividing by 6. We can just keep it as is. Because all of the calculations that came after that were consistent with the 6 tablets, not with 1. So that is for 6 tablets. Now, to find the amount of, to find the mass in 6 tablets, we just times this by the MR of MgO, which is, if you look on a periodic table, add the MRs would be 40.3, and multiplying that together, you get 0.6379 grams. And now the final step is obviously, like I said, we're using the 2.41 grams. So we divide this by 2.414 to find how much MgO is actually in the tablets, times by 100, and we get a very not too great percentage. If you want to find the actual amount of MgO inside the tablet, it's only 30%, right? So there we go, 29.8%. So quite a difficult question there. That's the reason why it's 6 marks. But it's the same layout almost every time with these back titration questions. You start from the back, start from step 7, you work your way up, and you figure out, what was originally in my kind of equation. Obviously, we had to use part B here, which they often will get you to do, and then, subtract it to find what actually reacted, right? Because this part here was for the titration. Okay. And that is it. Thank you.